All right, in this next problem, you're going to determine the rate law from some initial rate data. So we're given a reaction here, 2A plus 5B plus 6C gives us 3D plus 3E. All right, in the rate of the reaction, we're going to see what effect the concentration of A, concentration of B, and concentration of C have on the rate of reaction is how we'll determine what their coefficients are. So the generic rate law here, rate is equal to K times the concentration of A to X, we don't know the value of X yet, times B raised to the Y power, we don't know the value of Y yet, and C raised to the Z power, don't know the value of Z yet. What I can do here is take this rate data and compare it and figure out what the value of X, Y, and Z is. So I'm going to take experiment 2 and experiment 3 here to try to figure out what X is. The reason I picked those to figure out X is, so concentration of B, concentration of C are the same, so only the concentration of A is changing. So that's the only one that can give me information about the value of X. So then rate 2 divided by rate 1 is equal to 2.4 times 10 to the minus 3 over 1.2 times 10 to the minus 3. Should be able to see pretty easily that's equal to 2. 2.4 divided by 1.2. And so now for rate 2, it's going to be K times the concentration of A raised to the X power, the concentration of B raised to the Y power, and the concentration of C raised to the Z power. Okay, and then rate 1 is equal to concentration of A to the X, concentration of B to the Y, concentration of C to the Z. All right, well, this is where the magic happens, is we've picked these such that it would be impossible for us to simultaneously solve for X, Y, and Z, but what we can do here is we've picked, so regardless of the value of Y, since since this value within the parentheses is the same, it cancels. So that gets canceled. This gets canceled. K is a constant, so it gets canceled. And so what we're left with here at the end of the day is 0.20 raised to the X, 0.10 raised to the X, which is the same as 2 raised to the X. Okay, if I divided the top and bottom here by 0.10, this is what would happen. And that is equal to 2. So this part yields this part, and this is just me rewriting that. So it should be pretty straightforward here then to see that X equals 1. X must be 1 for that to be true. All right, gonna look back up here at my data. I want to figure out what Y is now. So I'm going to look for trials that only have a change in B. So if I compare 1 and 3, A is the same, C is the same, B is changing. Rate 3 divided by rate 1, 0.8 times 10 to the minus 3, 1.2 times 10 to the minus 3. Should be pretty easy to see that's a 4. 4.8 divided by 1.2. And going to do the same thing we did with the other part there. So K times 0.1 to the X and 0.20 to the Y and 0.10 to the Z. That was for trial 3. Now I'm going to do my trial 1 again. K times 0.1 to the X, 0.1 to the Y, 0.1 to the Z, and we're going to get that nice cancellation again. So same term here and here, here and here, k is k. And so in this instance now, we're left with 0.20 to the y over 0.10 to the y, which is 2 to the y is equal to 4, and therefore y must be equal to 2. The most difficult of these is this last trial to figure out z. So I am going to compare. I need something where everything else is constant. Okay, if I compare trial 2 and 4, okay, that's the same, that's the same. Okay, we look good here. All right, we're going to divide, I'm going to divide rate 4 by rate 2. Pretty interesting here with the rates. So the same, so it's equal to 1. So we're going to get this nice cancellation again. These terms fall out, k's fall out, the y's fall out, and so we're left with .30 y, 0.10 the y, that's 3 to the y equals 1. Okay, and that's only true, what am I talking about? Z, that's only true when z is equal to 0. All right, we're almost done. So now we have our rate law is equal to k times a to the first power we figured out, b to the second power we figured out, and c to the 0 power. So the problem also asks you to figure out the value for k and the units for k. Well, we can go back in and we can put any trial in order to do that. So I'll do trial 1. Our rate is 1.2 times 10 to the minus 3 is equal to k times 0.1 to the first power, 0.1 to the second power, 0.1 to the 0 power, .2. All right, and last thing, for every rate that we talk about, the rate is molarity per second. Okay. And so for this to be true, k would have to have units of m to the minus 2, s to the minus 1. Okay, m to the minus 2 cancels this part out, s to the minus 1 adds the s, and so if we had this as our unit right here, this equality would be true. So we're looking for k equals 1.2 m to the minus 2, s to the minus 1.